Mathematics 2, Integration by Parts. We want to integrate e to the minus omega t sine omega t plus 3. To do this, we have to use integration by parts. Let's just remind ourselves what that means. From differentiation, we know that the differential of uv, where u and v are both functions of x, is equal to u dv dx plus v du dx. So if we integrate both sides, we get that uv is equal to the integral of u dv dx with respect to x plus v du dx with respect to x. And if we rearrange that, we get the integral of u dv dx is equal to uv minus v du dx. So what we're going to do is we're going to let e to the minus omega t equal u and sine omega t plus 3 equal dv dt. So now we need to differentiate e to the minus omega t and we need to integrate dv dt. So differentiating, we're going to get minus omega e to the minus omega t, and integrating, we're going to get the integral of sine omega t plus 3 is equal to cos omega t plus 3 over omega. And at this point we should do a sanity check. If we differentiate cos, we get minus sine. So if we differentiate minus cos, we get sine. So the differential of minus cos omega t over 3 is going to be sine omega t over 3. And then we multiply by omega because of the chain rule, which means that this additional omega here, it cancels out. So now what we're going to say is that the integral I is equal to uv minus v du dt. So this is equal to u v, which is minus cos omega t plus 3 over omega, minus v du. Now we have omega here and omega here, so they will cancel. And we have a minus here and a minus here, so they will cancel. So we can write that I is equal to minus e to the minus omega t cos omega t plus 3 over omega minus e to the minus omega t cos omega t plus 3 dt. And I'm going to call that equation 1 because we'll come back to that. Now at this point, it doesn't look as if things have improved much. We have a first term which doesn't need integrating, but we have a second term which is not very dissimilar to where we started. So what we'll do now is we'll call this part I1, and I will ignore the minus sign here, but do keep it in mind. So we're going to say that I1 is equal to the integral of e to the minus omega t cos omega t plus 3 dt. So as before, we're going to let e to the minus omega t equal u1 and cos omega t plus 3 equal dv1 dt. So we need to differentiate u1 and integrate dv1 dt, giving us minus omega e to the minus omega t, and v is equal to sine omega t plus 3 over omega. So if we put this together, we're going to get u1 v1 minus v1 du1 dt. As before, we can cancel the omegas, giving us I1 is equal to e to the minus omega t sine omega t plus 3 over omega plus e to the minus omega t sine omega t plus 3 dt. Now, if we look at that and we go back to the top, we see that that is our original integrand, which means that this piece can be replaced by I. And now if we substitute I1 back into equation 1, which is here, we're going to replace this with I1. Remember there's a minus sign here. We can expand this bracket, giving us e to the minus omega t cos omega t plus 3 over omega minus e to the minus omega t sine omega t plus 3 over omega minus I. So if I add I to both sides, we get 2I is equal to, and this time I'm going to take minus e to the minus omega t over omega outside of a bracket, giving us cos omega t plus 3 plus sine omega t plus 3. So then all I need to do now is to divide both sides by 2, giving the integral I is equal to e to the minus omega t over 2 omega cos omega t plus 3 plus sine omega t plus 3 plus our constant of integration. And that is how you do integration by parts.